the Boston Red Sox spring training stadium case study, and they want you to do a center of gravity, first of all, around where the population centers are. Now we have 4 potential locations. These are all the 4 locations and the coordinates. But the first thing I did was look at where the population centers are. The biggest population is over here. But these are the coordinates of the population centers. This is the population, and when you do a center of gravity of that, you can see that your center of gravity comes out to about right there, and then transposed to this graph where I include that center of gravity from up there, and then I put the potential sites. So these are the potential sites, and the one that's closest, which looks like it's either A, B, or D. So A, B, or D become candidates. C is probably not a candidate anymore based on the center of gravity if you wanted to make that decision. But it looks like A would be the one that's closest. So that would probably, the center of gravity analysis, you would probably pick A. Question 2, where they want you to use a weighted scoring model. So this is where we're going to use our multi-criteria and decide. And we've got 2 different types of data. First of all, we have cost data. So that they give us for each of these 4 locations the stadium cost, the utility, and road development. These are the cost. So these are the total costs. So you can see the cheapest one by far is location C, which again, that's probably furthest away from center of gravity. I don't know if we ought to consider that, but even if we do, it's you can see it's a long ways from the center of gravity. But if you do include those, the trick is how do you include these numbers with these numbers where we have other drivers. We've got environmental group endorsement, congestion, the ability to get a permit, long-term economic growth, and the chance to preserve county. So how do I combine these numbers? These are the costs, where that's the cheapest one, this is the most expensive one, with these factors. And there's lots of ways to do this. Let me show you one way. I'm not saying it's the best way. It's a little bit convoluted, but this is what I did. The first thing I did is that all of my numbers are going to be scaled between a number 1 and 5. So you can see that for my cost, ultimately I'm going to come up with a number between 1 and 5. Where this would be my worst one, this would be my best one, this one is this, and this. So how did I come up with these numbers? And then later on, I also have for my qualitative measures, these are all converted to a number between 1 and 5. So once I've got the cost put into a scale of 1 to 5 and my qualitative 1 to 5, I can put a weight to each of these, and then I can score those based on using the multi-criteria. So first of all, how did I take these numbers that are in millions of dollars, I think it's millions, and convert those to a number? So my smallest is an 18, my biggest is a 24.5. So what I want to do is I want to assign a number. The first thing I did was put it on a scale where 18 was set as 0 and 24.5 was set to 1. So that's my min, that's my max. So how did I get these numbers? This is totally not the total cost. How did I get these numbers? They're based on the minimum and the max, 18 and 44. And I could have put any 2 numbers I want, but I just put the min and the max. So look what I did. This formula, it's an interpolation formula. What I did was look at C20, 21 minus 18, the minimum. So that's my numerator. It's the difference of this score from the minimum divided by the difference between 24 and 18. So you can say on a continuum from 18 to 24.5, if I would interpolate, a linear interpolation of that, 21 is 46% of the way. So it's kind of in the middle. 23 is closer to 24.5, so I'll get a 0.77. And again, it's this number minus this one in my numerator divided by the difference between this and this. And then 18 is way over on the left of my continuum, so I got a 0, but it's the same formula. And then this is the max, so it gets a 1. So that's how I got these numbers, but I want bigger is better. I mean, bigger is, or smaller is better. So I need to reverse scale these. So these are on a scale between 0 and 1, but I want 1 to be 0 and 0 to be 1. So look what I did. All I did was reverse scale by taking 1 minus whatever that number is. So now, because smaller is better. So now this number, because it's the lowest cost, has a 1. This is the biggest cost, has a 0. And then these are somewhere in the middle, where this one is more expensive, so it's got a smaller number, smaller scale than this. So that's the best one, that's the worst, this is the second best, this is the third best. Then, remember, I'm trying to put this into a multi-criteria. I want to scale it from 1 to 5. So if I'm at 1, you can see that became a 5. If I'm at 0, that's a 1. 1 is the best, so I get my 5. That's my best. 0 is my worst, and so that's why I got a 1. But the formula that I used for all of these is 1 plus, 1 is the minimum, plus my 0.54 multiplied by the difference between this and this. So it starts at 1, or I probably shouldn't have put 1. I should hard code that. That is the starting point, plus my reverse scale number, which is a number between 0 and 1, multiplied by the difference of 5 and 1. So that turns this 0.54 on a scale of 0 to 1 to a 3.5 on a scale of 1 to 5. Somewhat complicated. I used interpolation, used a reverse scale, scale it to 1, standardized to 1 and 5. So from all of that, the one that is the best from a cost standpoint is C, which we knew from the beginning, but now we've got a continuous number. 1 is the worst. That's the one that's most expensive. So now that I've got these numbers, I put those down here. Now the rest of this is what the data was given. We know almost, no, no, and yes. So every one of these I had to put on a scale of 1 to 4. So over to the right, the very first one, no was a 1. I only have 3 choices, no, almost, and yes. So I just put no there, almost in the middle, and yes. And the next one had a score of poor, moderate, and good. I don't have anything else, but I put poor, moderate, good. I probably shouldn't have used that, but that's what I chose, poor, moderate, good. I put it very good. So no one could score more than a 3 on this because I don't have any very good or excellent. I've got not ready, mostly ready, and ready on a scale. I put it on a 1 to 5, so that's what these are. These were easy on a scale of 1 to 5, so that's a 4 on a scale of 1 to 5, so that was an easy one to do. And the last one, we have low, moderate, and high. So with this being my scale, and this is the data for each of the 4 categories, that means that this almost becomes a 3. And the no becomes a 1. How did I do that? Is I used a cool formula called match. You didn't, and by the way, you didn't have to use any formula. You could have just looked at almost and said almost is a 3, and I could have just typed a 3. But there's a cool formula in Excel called match. And what the match formula does is that it looks up C28, it looks up almost in this, and it's going to give an index, a number. Since that's got 5 columns, it's going to return the appropriate column. So in this case, almost is in the 3rd column, so that's why it returns a 3. So every one of these is using this match. And the last argument is looking, I think, for an exact. A match type, it's exact. Okay, so those numbers are the qualitative numbers. This is from my cost. I now put a weight to this. This is my choice. The thing that's most important to me is long-term economic growth. I put it 40%. You didn't have to do that. And then I put cost as my second, and everything else I weighted equally to 100%. And then, so each of my locations is graded using the multi-criteria, which is I use the sum product, this times this. So this, and now I'm looking for higher the better. This is my preferred location, location A, where location D is second, C is a third, and then B is a distant fourth. So using this multi-criteria that combines cost, it looks like A, D, C. Up in my center of gravity, the preferred one was A, B, or D, C. So it looks like if it was up to me, I would probably choose A based on this value and this, and maybe D. D would be my second choice. So these would be my top two choices right there. Okay, that's my analysis. I think there's some other questions on that. I'm not going to worry too much about that. Thanks.